Hi, it's Rob again from Engineers Academy. In this worksheet, we have a table of data representing machine stoppages on a shop floor. With large tables of data, it can be difficult to determine what is happening by simply looking at the numbers presented, and that's the case we've got here. By analyzing the data using a Pareto chart, the data is put into a visual format so it can be used for some basic initial analysis. The data table has 4 columns that are below the title. We can see a reference number column followed by a date column, giving the date and the recorded stoppage occurrence. The first 2 columns are not particularly significant for the Pareto chart, but can be useful for further data analysis. The last 2 columns tell us each day the number of times that a machine has stopped production. So in this case, we can see that the welder on the 13th of January stopped twice. These last 2 columns are the columns that are used to create the Pareto chart. Looking at the Pareto chart now, we can see that it is a tool that can help us visualize and prioritize the most significant factors that contribute to a problem from quantitative data. Looking at the first red bar here in the chart, we can see that it has the largest count of stoppages. 147 of our stoppages occurred because of the lathe, and this is out of a total of 265 overall stoppages. Secondly, we can see that the welder, the green bar here, had 51 stoppages, the plasma cutter 34, and the grinder 33. By using a Pareto chart when initially analyzing basic data, we can get a quick idea of the factors that are likely having the greatest impact, in this case the lathe. You will also notice on the chart we have a bar rising from left to right. This bar represents a cumulative percentage as we read across the chart. The scale for this is the vertical axis on the right hand side. If we look at the start of this line, we can see it starts at the lathe where we've got our 147 count, and this represents around about 55% of our data. If we then go on to add the welder, it takes us up to approximately 75% because we're adding another 20% here. And as we go along this chart, we should see that by the time we get to the end, 100% of our data should be accounted for. With this chart, we can immediately see that over 50% of our stoppage occurrences are due to the lathe stopping 147 times year to date. This suggests that if we can solve the problems on the lathe alone, we will be able to eliminate more than half of all the machine shop floor stoppages. Pareto charts are good for quick referencing basic data, but they lack analysis detail. For example, we cannot tell the duration of each stoppage, and we cannot see the reasons for the stoppages. So we don't know if the stoppages had one single repeated cause or many different ones. If I remove this one, we can create another one. Creating a new Pareto chart is relatively easy. By highlighting the data labels at the top of the 2 columns that we're interested in for our data, the machine type and the number of stoppages here, we can press Ctrl, Shift and down to select our 2 columns data that we want. We actually don't want that last one. We then go up to our Insert bar and we select Statistical Charts. We take the right hand chart from the histogram row, click on that, and immediately we've got an inserted Pareto chart ready made. And as you can see, the data is exactly the same for the one that we previously had. But in order to improve it, if we click on the chart, we can then get the chart design tab at the top and look over the add chart elements. Selecting data labels from there, we can put in some data labels. It gives us our numbers. And then we can go on to color each bar. By left clicking each bar, we can select the paint pot from the format. We can then choose our colors that we want. And I'm going to take red for the first one. Select the second bar. And I'm going to make that green. Select the third bar. I'm going to make that purple. And the last bar, I think I'm going to make yellow. Finally, we can edit our chart title by double clicking on it. We can either retype in the title there, or we can select our data and copy it into our chart title. So there we have a Pareto chart for our machine shop stoppages that gives us very quickly a visualized result. Here we have another table of data. This one gives us a weekly garment returns from a garment shop. And we can see the reasons in this column for why each garments are returned. So by category of the type of defect that we have. So some are returned for damage, poor quality, too big, too small, or wrong items. And this is by the week number through the year. And again, we can't tell anything significant just looking at the data here, but we can create a Pareto chart that gives us some quick results. So let's have a quick look at why this is happening. So again, highlight the two top labels of the columns, Control Shift down, go up to Insert, go to our statistical charts, select Pareto chart, and again we can see that the major reason for returns of garments is because the items are generally too big, and secondly we have damaged items, closely followed by the wrong type of item being packed. Again, we can put some labels on this by going up to Chart Design, Add Chart Element, Data Labels, and put some data labels on here. And in this case, the reasons for return because items are too big accounts for over 50% of our issues. So if we can address this problem, we will significantly reduce our returns issue.